Hi, so in this tutorial, I'm going to give you some very important derivatives that you need to actually remember. So let's just jump right to it. So let's take, um, sorry. So let's start by saying, let's make a table. Let's call all of this y or maybe f prime of x. Okay, then at this column, we're going to have the derivative of each of them. That's either dy over dx or maybe f prime of x. So the first one I'm going to talk about is the if you are given any function where we have a to the x power n, the derivative becomes an x n minus 1. So it means that you need to just reduce the power by 1, but before you reduce the power by 1, you need to multiply the exponent by the coefficient of the variable. Then when you're done, you reduce the power by 1. I think this is the basic one that we all know. Let's take the second one. Second one is sine of ax. Sine of ax. Now what we do is that if you are asked to differentiate sine of ax or sine of a particular angle, what you do is that you differentiate the whole function. If you differentiate sine of ax, you get cos of ax. But when you are done, you need to differentiate the angle itself. So if you differentiate ax, you are going to get what? A. So this becomes the differential of sine of ax. I hope you understand that. Yes, so if you have just sine x, sorry, where should I am right here? So if you have only sine x, then the differential of sine x becomes cos x times the differential of the angle. And we know that the differential of the angle x is just 1. So you're going to have still cos of x. But if it was sine of 2x, becomes 2 cos 2x. Why? Because if you differentiate the whole function of sine 2x, you get cos of 2x. Then the differential of the angle 2x gives you 2. So that is it. It's very important, you need to just keep in mind. Then the next one is cos of ax. So if you are given cos of ax and you need to differentiate it just as we did for the previous one, if you differentiate cos of ax, you have to differentiate the whole function before you come and differentiate the angle itself. So if you differentiate cos ax, you're going to get negative sine ax. Okay, then you multiply it by times the differential of the angle. If you differentiate the angle ax, you're going to get a. Okay, so we're going to get times a. You're going to get times a. So in all, we're going to get negative a sine ax. That becomes the derivative of cos ax. Now let's move on to the fourth one. Let's take e to the power of ax. Okay, e to the power of ax. We know that e to the power of ax, whenever you differentiate e, you get the same thing. So what we're going to do is that we are going to differentiate the whole function, which is a to the ax, and whenever you differentiate, like I said, you're going to get the same thing. So you're going to get e to the exponent of ax. When you're done, you have to differentiate the exponent and multiply it by it. So if you differentiate ax, you're going to get what? A. So this becomes the differential of e to the ax. Then finally, the last one, very important, is the natural log ln. Ln of ax. How do you differentiate ln of ax? So to differentiate ln of ax, you are going to get 1 over x. Now, the reason why you are getting 1 over x is because ln of ax is actually written as, let me bring you down here. Yeah, so ln of ax can be written as ln of a plus ln of what? X. Now, this is a constant because it doesn't have any variable. So we are going to get 0 for this. Then ln of x will give you 1 over x. So that is the reason why the differential of ln of ax becomes 1 over x. So if you are given, let's say, ln, you're asked to differentiate the function in terms of x as maybe 2x, let's say, yes, something like this, then it means that the differential becomes 1 over x. The reason is ln 2x can be written as ln of 2 plus ln of x. This gives you 0. This gives you 1 over x. And in the same way, if you're given ln of x, the differential of ln of x still becomes 1 over x. Hope you get it, because you can only write, this is even just the same as this. This is the same as this. So you see that. All right. I hope this video is very clear and you understand it.